So today we're going to be talking about energy pyramids and how you can take just either an energy food web or a food chain and put it directly into an energy pyramid, and you'll see how well it translates. But it gives us another picture of the ecosystem that we're looking at. So let's get to the slides. All right, same thing. Looking at how energy flows through either food chains, food webs, or the energy pyramid. Okay, that's what they look like. So when we use energy pyramids, and here's like 2 examples I found off the web and stuff, says an energy pyramid is an image or graph showing the flow of energy at each trophic level. And trophic means feeding, eating level in an ecosystem. The width of the bar represents the units of energy available within each trophic level. So I want you to notice right off the bat that the biggest bar is down here because it's a pyramid, and the smallest one is on top. There's more energy at this level than there is at this level. Okay?
You're not sharing your screen.
Oh, thank you. Let me first admit this person, and let me share my screen with you.
I just lagged out completely.
You did what, hon?
My meeting froze and it just kicked me out.
Oh, okay. Okay, that's fine. Thanks for coming back. I can pull this down. There we go. Alrighty, let me just recap a little bit of, it's exactly what I did this morning. So it's a repeat. No, I don't want to share. I want to present. All right, so this was the slide that I was showing. The other one is not important. But here we have the energy pyramid, and it's a pyramid. And again, the widest one at the bottom.
You're on mute.
Oh, Lord. Thank you. Boy, I'm having a great day video recording this. The widest thing is at the bottom because that's where most energy is. As you move up the pyramid, you get less and less energy that's pushed along, okay? And we're going to see that what's at the bottom, what the most energy is, are our producers, okay? And then it just all moves from there. So let's take a look at what they are and how you would take this food web and translate it into an energy pyramid. So we have to find the producers. So we already established yesterday that the kelp and the phytoplankton were the producers in this coastal food web. They are going to go at the bottom because they are what we call producers or autotrophs. They make their own food. The only energy that they get from anywhere is from the sun, and the sun is not an organism, okay? They're the ones that start everything off. They're the ones who occupy this largest space. They're the foundation of any ecosystem as far as bringing food into that, or energy into that ecosystem. So those are our first level, our producers. And then on the next level is going to be the sea urchin and the mussel. And why do y'all think they're on the next level up?
Because they're primary consumers.
Exactly. They're the primary consumers. They're the first ones, primary means first, they're the first ones to get the energy from the producers. Okay? So they're the first ones that are going to be able to taken, that energy. I'm skipping like a couple here. Oh no. So they take that energy directly from the producer. Okay, just got made right there, and they're going to be the ones to eat it. And remember, just to remind you, heterotroph means that it's an organism that must consume, plants or animals in order to survive. We're going to see a lot of the examples you're going to see are going to be things like, grasshoppers or mice or, those kind of things. But understand that, bears can be primary consumers as well because they're omnivores, right? They eat producers as well. So this is not reserved for just a certain type of organism, but just anything that eats plants, like cows or grasshoppers. So the energy from the producer goes directly first into any organism, any animal that eats plants. They're considered the primary consumers. In our example, it happens to be the sea urchin and the mussels. Okay, second in line to get the energy from the producers. And remember, it's going to come to these guys via these guys. The organisms and the secondary consumers are going to have to eat one of the primary consumers in order to get that energy that was started down there by the plants. So they're called secondary consumers. So if we look at our coastal food web, who would that include? Who would be second in line to get energy from the kelp and the phytoplankton?
The crabs and the sea storm.
Crabs, yeah, because he's primary, he's secondary. Primary, secondary. Anybody else? Well, these are the guys as well, because here, primary, secondary. And the fish, how is the fish secondary? Let me see this one here. That would make him a tertiary. And I think I listed him as a secondary. Okay? But he's a tertiary because he's not directly eating, unless I just sneak in an arrow right there. But yeah, I need to probably erase this one. He's a tertiary. But these guys, they're second in line in getting the energy from the producer. Okay, yeah, the fish, I need to change that. Alrighty, and they're heterotrophs. They don't make their own energy. They have to consume others. Secondary consumers are secondary consumers because they consumed the primary consumers. And then the third line, and I've seen it up to like 5, and in nature, usually it doesn't go 5 because by the time the apex predator would be eating whatever, there's not much energy left. And we'll talk a little bit more about how energy or how much energy is passed along. But just understand, those primary consumers, they got their own little lives to live, and they needed to jump around or molt their shells or mate, whatever it is that they run away, fly away. They need energy so that when they ate those plants that are producers, they're going to use that energy to live. So when the secondary consumer comes along and eats them, they don't have all that energy they got when they first ate that plant. They've used some of it just to live. So the tertiary one is just that. It's the third one in line from the, but I'm adding fish to this, third in line to, from the producer. Okay? So the easiest way to do this is count the arrows. 1, 2, 3, tertiary. 1 arrow, 1 arrow. 1, 2, that would make him. And so I want you to see that also, like we can go 1, 2, 3, and the sea otter is not only secondary, but he's also tertiary. So, there's no like set thing like, no, sorry, Otter, you can only be, secondary. That's not true. It just, depends what's happening in nature. Or an animal doesn't fit into just one, this is their level and there they shall remain. Because we can see that that's not true even from this simple example, much less nature. Okay, so at the top we have what we call the apex predator. This is the top of the food chain. And you'll see that there's less of them. Think of the wide base of the pyramid with plants. There's a lot more what we call biomass. Biomass is like if I took 1 square mile of land, South Texas somewhere, and I scraped up all the trees, plants, grasses, anything plant material, and I literally like weighed it all on a giant scale, I would have more plant matter than I would have animals. Okay? There's just a lot more plant matter than animals. And we need it to be that way. We need to have a lot of food down here to be able to sustain eventually everybody all the way up here. But we're going to see that tertiary consumers at the top, the apex predators, they need to consume a lot. They need to eat lots of crabs and lots of otters in order to sustain themselves. So, yeah, more energy down here in the plant level. And it's freshly made from the sun. All right, let's watch this little...
Every day in nature, energy is being transferred. Energy from the sun is transferred to these plants. And then insects may receive energy from the plants. And then a snake may receive energy from an insect. An energy pyramid is a display of energy flow in a community. The different levels represent different groups of organisms and where they receive energy. Welcome to Moo Math and Science and Energy Pyramids. Let's take a look at an energy pyramid in a typical ecosystem. You will find producers at the bottom of the energy pyramid. Examples of producers are plants. Plants are autotrophs because they use sunlight and photosynthesis in order to produce glucose, which can be converted to energy. They do not rely on other organisms for energy. Plants take sunlight plus carbon dioxide and water to produce glucose and oxygen. Plants make up the base of an energy pyramid. The next layer includes primary consumers. These organisms are herbivores because they eat producers or plants. Examples are insects, cows, horses, and any other organisms that live exclusively on plants. The next level includes your secondary consumers, which include carnivores or omnivores. Carnivores consume primary consumers, and omnivores eat producers and primary consumers. Examples include frogs, lizards, many snakes, and many birds. Above the secondary consumers are tertiary consumers. Tertiary means third level. They consume secondary consumers. This level includes carnivores. Examples would include wolves, lions, and this hawk. Each layer of the energy pyramid is called a trophic level. And as you move up each trophic level, 90% of the energy is lost, much of this to heat, and only 10% is transferred to each layer above it. If you'd like to know more about energy pyramids, this playlist will help. And as always, Moo Math uploads a new math or science video every day. Please subscribe and share.
All right. And then I've got this other video we showed every year, but it's like translated through like a computer or something. The verbiage is really bad and stuff, but somehow we get a kick out of just showing it.
If you want to see more science videos, go to www.makethegenius.com. Oh, yeah, and it's free.
was so tired and hungry, I wanted energy to continue. Do you know why we need food? Okay. You know we need food to get energy. Energy is required by living beings for growth, also for movement. We need energy. Similarly, when species reproduce, they need energy. Also, as grow up or grow old, our old tissues get damaged or new cells are produced. This process also needs energy. Now, from where this energy comes from? Most of the living species use sun's energy. This energy is transferred to body via food they eat. Sun gives light energy, which is used by plants to make their food by photosynthesis. These plants are eaten by primary consumers and energy is transferred to them. Now secondary consumers eat these primary consumers and energy is transferred to them too. So does giraffe get all the energy from plant which plant gets from sun? Or does lion gets all energy from giraffe which giraffe gets from plant? The answer is no. Actually, 90% energy is lost when it passes from one part of chain to other. Like 90% energy is lost when giraffe eats plant. Similarly, 90% energy is lost between lion and giraffe. Look at this pyramid. It is called energy pyramid. This shows that energy available becomes lesser and lesser as we move on the top of food chain. To understand energy pyramid, let's assume plants absorb 1,000 units of energy from sun. When giraffe eats it, 90% energy is lost, so giraffe only gets 10% of energy. This means energy transfer from plant to giraffe is 105 of 1,000 units of plant energy, which is 100 units. Now when lion eats giraffe, 90% energy is again lost, and lion gets only 10 units of energy. So now you know more about food and energy. Can you give me one more bite? Please give me one more bite. You already have so much energy. I need more food to get more energy. Sorry, man.
It's a strange little video. The information is actually good, but yeah, the sort of computer translation, or I don't know, somebody didn't do a good job at that.
Every
Anyway,
day in nature, energy is
that is the end of what I have for the lesson, and we'll continue just to talk a little bit more about this. But I hope you saw how easy it is to translate a food web or a food chain into an energy pyramid. Now, the end of this little monkey video talked a little bit about what we're going to be including on this, which is how much energy does move up. Because at every level, that organism needs that energy to do, live their best life. So the grass takes in all that energy from the sun, but it's going to use some of that energy. It's got to grow roots and leaves and fruits and flowers and whatever else it may need to do. And then when the rabbit eats it, it doesn't get all the energy the plant had because the plant is using some of its energy. And likewise, whatever the rabbit eats, he's going to use some of the energy from that grass he ate to, have bunnies and hop around and dig and run away from predators. So whoever eats him isn't going to get all the energy that he consumed while eating the grass either. So we're going to see how that fits, and it's the 10% rule is what you have to remember. Alrighty, guys, so I'm through with this. If you would just go ahead and hop into the assignment for the day. There is the discussion question. You have a question, Brianna? No? Alrighty.
Yes.
Yes.
I'm done.
Oh, okay. Woohoo! Yeah, when you finish, you're free to go. As long as you finish the discussion and the assignment, you're done. Thank you so much. Have a good day.